A proportion is simply when two ratios are equal. If we have four non-zero numbers a, b, c, and d, then they are in proportion if a colon b equals c colon d. In other words, a divided by b equals c divided by d. We write this as a, b, c, d. For example, the numbers 2, 3, 4, and 6 are in proportion because 2 divided by 3 equals 4 divided by 6. Notice how the balance between the ratios shows up clearly. In a proportion A, B, C, D, the four numbers are called the terms of the proportion. Here, A is the first term, B is the second term, C is the third term, and D is the fourth term. The first and fourth terms, A and D, are called the extremes. The second and third terms, B and C, are called the means or middle terms. So in our earlier example 2, 3, 4, 6, the extremes are 2 and 6 while the means are 3 and 4. This distinction is important because it leads us to a very useful rule. If a divided by b equals c divided by d, then cross multiplying gives us a times d equals b times c. This is called the cross product rule. It simply means that the product of the extremes is equal to the product of the means. For example, in 2, 3, 4, 6, we have 2 times 6 equals 12 and 3 times 4 also equals 12. Balance achieved. This rule is not just a trick, it's the foundation for solving proportion problems in both algebra and geometry. When four numbers are in proportion, the last number is called the fourth proportional. If A dash B saw C, D, then D is the fourth proportional to A, B, and C. For example, if A equals 2, B equals 3, and C equals 4, then D is found by multiplying B and C and dividing by A. That is, D equals 3 times 4 divided by 2, which equals 6. So we get 2, 3, 4, 6. This concept is used in scaling models, construction drawings, and even in map ratios. Now let's extend this. Quantities are in continued proportion when more than two ratios are equal in a chain. For example, if a divided by b equals b, divided by c equals c divided by d, and so on. In particular, three numbers a, b, and c are in continued proportion if a divided by b equals b divided by c. Take the numbers 2, 4, and 8. They are in continued proportion since 2 divided by 4 equals 4 divided by 8. You can see the pattern. Each ratio links smoothly to the next. When three numbers a, b, and c are in continued proportion, a is called the first proportional, c is called the third proportional, b is called the mean proportional. Now, for the mean proportional, if a divided by b equals b divided by c, then b squared equals a times c. That means b equals the square root of a times c. Let's solve one exam-style problem. Find the third proportional to 5 and 20. Step 1. If a divided by b equals b divided by c, then c is the third proportional. Step 2. From the rule, c equals b squared divided by a. Step 3. Substituting a equals 5 and b equals 20, we get c equals 20 squared divided by 5. That is 400 divided by 5, which equals 80. So the third proportional to 5 and 20 is 80. Notice how the method flows directly from the cross-product rule. So, to wrap it all up, a proportion is the equality of two ratios. In it, we identify extremes and means. The cross-product rule tells us extremes times extremes equals means times means. The fourth proportional is the number that completes the set. Continued proportion extends the idea across more terms, and the mean proportional is the square root of the product of the extremes. Proportion is not just a textbook topic. It's a tool we use in designing, enlarging, comparing, and scaling in real life. And that's the essence of proportion. In the next session, we'll take this further into applications of proportion in geometry and algebra. Stay tuned and keep the curiosity alive.